All right, let's do the rest of these problems on the sample test. Number 6, we're supposed to find a of x, the function of x, without the integral. Well, there's no derivative in here, so they don't cancel, so we actually have to find the antiderivative of this. And if we let u be t squared plus 3, du is going to produce this 2t dt, and when we solve for dt, that 2t is going to be under du, and that t is going to cancel that t. So this is going to become the integral, and it will no longer be 2 to x if we change to u. So I'm just going to put question mark to question mark. There's a t, and then there's this, which I called u, and then the dt is du over 2t. The t's cancel. The 2 can be pulled out as 1/2, and then I'd have the integral of 1 over u du with unknown limits, and the integral of 1 over u is ln u, and we'd be evaluating from something to something that I didn't figure out. Now I could have put the 2 into here for t and figured out what the u is on this side, and put the x in here for the t and figured out that one. But I'm going to switch it back, so this will be 1/2 ln absolute value of u was t squared plus 3. And I got to evaluate that. Now I can go back to my t limits, 2 and x. And so I get 1/2 ln absolute value of x squared plus 3 minus 1/2 ln absolute value of 2 squared, 4 plus 3, ln of 7. And that would be what a of x is. So this is a function in x. This changes as x changes, and this is a constant that's added on. And that would be how you do number 6. Number 7. Okay. If we integrate first, we'll find the antiderivative of this, but I don't want to have to find the antiderivative of this. Since there's an integral and a derivative, they kind of cancel each other out. And we talked about that. Same here. We have an integral and a derivative. They kind of cancel each other out. But there's subtleties that we need to look at. If we integrate that and got some antiderivative of it, then we'd have to put in x, and we'd have to put in 2, and we'd subtract those 2. Now, if I took the derivative of this with respect to x, well, the derivative of f of x would be just back to this with an x in place of the t, so we'd get the square root of x over x squared plus 3, and then the derivative of the constant would be gone, and so this would be my final answer. If this is x, doesn't matter what this is, x is going to replace the t's. If this was x squared, we'd be putting x squared in here, and chain rule would say we'd have to do the derivative of f of x squared, and it'd be x squared in for these x's, but then we'd have to take it times the derivative of x squared, which is 2x. So really, if the derivative is on the outside, you put whatever this is, x or x squared, in for the t's, and times the derivative of that. In this case, the derivative of that is 1, so we didn't have to worry about it. If the derivative is on the inside, this is already capital F of t. So if we took the derivative, we'd get little f of t. And then we'd have to integrate it, which should take us back to the capital F of t. This, and we got to put x in for the t's. So it'd be the square root of x over x squared plus 3. Just replace the t's. Minus, we'd put the 2 in, and so we'd get 2. And 2 squared plus 3. The constant stays here. And there's no chain rule because we're not taking the derivative after the x has been put in. Here we're taking the derivative after the x is put in, and so if it's x squared we put in, we have to take it times 2x. So that's the difference between the derivative on the inside versus the outside. And I want to know if you can keep that straight. And finally, this one. This is the derivative. We're supposed to draw the regular curve, the antiderivative. And I want it to go through 2, 8. So at 2, we're here. This area is negative, so the graph has to go down. And let's see. This is -2, and this is from here to there. That's from 2 to 10. That's 8 by 2, 16 in half. 8, negative. So I got to go down 8 by 10. And it's got more negative velocity here than here. The velocity goes to 0. This is linear, so it's got to be parabolic. And this area looks like it's the same as this, only plus 8. So I'm going to go back up to 8 by 18. That's this part. Now, the part the students have the hardest time with is this is negative area. It's goes from -2 to 2. That's 4 by 2. 8 in half. This is -4. This graph has to go down 4. Slope is 0, so it's parabolic but upside down. And if that's 8, that's 4. 8, 12, 4 more up by the time I get to -2. And at -2, the slope is 0. And then if you go further, it's going to go back down that same amount in the next 4. But it still keeps going down. Actually, this is positive, so it's going up. And it's going up this amount. Let's see. This is 2 wide by 1 tall, so that's 2, 4, 5. So it's got to go up 5 from here to there. That's 8, so 5 is about, 6 would be in the middle, 5 would be about there. And then this is 2, 4, 6. It's going to go down from here, down 6. So that's up 3, so it can be down 3, down 3 more, down 3 more, down 3 more, and it's going to continue to go, actually, this way it's going down, but this is positive area, and so it's going up as you go to the right. So that's what that graph has got to look like.